Okay, we're streaming at about 10 megabits, 30 frames per second. So this is another live stream where I'm going to go through playing a text-based MUD using a web front end. The original MUD is basically designed to be accessed through a telnet session. I could probably set one of those up just another day, just to show how we used to do things in the old days, so we say. So as it said in the description below, this database is basically run by what was a Tinymud engine. Tinymud originally implemented an in-memory database where there are rooms, players, things, and the rooms are connected with exits. Back in the early 90s, I expanded that model, added some extra functionality and removed some functionality from the game engine to make it more general purpose. And then as I took various C implementations of the adventure game, which is one of the original text-based games, and Dungeon, which came out as Zork 1, 2 and 3. I slowly added some extra functionality to make sure that all these games were implementable as fairly easily. So when converting, say, Dungeon C program to a multi-user game, the main thing was basically just to dump out all the rooms and objects that the game had into a file in the format of the Tinymud database, and then basically import that database into the game. And once that was in the game, then I had the exits between rooms was basically already set by when I did the extraction, but some of the logic had to be implemented using the exits and the lock functions on the exits. So that the lock functions are basically the programming interface to provide something that's other than a simple state machine. State machines are a very powerful technique. They're one of many ways of equivalents of doing programming. Most computers today will have a program counter and registers and large memory. The memory usually contains both instructions and data, and that is basically a very large state machine. So the program counter keeps track of which state you're in. The registers provide additional information about the state of the system. And on modern computers, the software and hardware work together to often provide multiple CPUs or cores so that they can easily do multiple things at the same time. So in a simple database engine such as the original Tinymud, there are only 4 types of basic object. There's rooms, players, things, and exits. And the database basically is a set of rooms connected with exits which form a state machine. And then the player is basically the objects. The players are the objects that move around, keeping and working out what their current state is. So it's all very much an equivalent system. So the way a computer works, the way this game engine works, the way electronics in many digital electronics works, are all basically the same thing, just viewed from a different perspective. So what we'll do here is we will jump into the dungeon. And so we have a web front end And what it's doing is basically showing us there's a mailbox and a door, and there's a description of the room we're in. So we can, the way I've set up the web front end is that if you click on an object, it tries to do a get command, and we can't take the door. Which, let's see, we can take the mailbox. No, we can't do that either. So that you see, so this is basically implemented by the database. It's not implemented by the engine. So we've opened the mailbox. Just drag this. Oops, sorry, wrong window. No, that's right. That's what I meant to do. Just drag that up a little bit. There we go. So we can do a get leaflet. Look, leaflet. So the get commands, the open commands, the look command are all implemented as part of the database, not part of the underlying engine. The underlying engine takes in what I typed and basically sends it as a message to the room. So when the room has obviously objects, exits, players, and what it does is the exits are treated as a dictionary. So what I type in is matched against all the exits that are in the room. Exits can have wildcard patterns, so that you can have get star, and star will match anything you put after the word get. So you could say get impatient, get angry, and that would match an exit called get angry. But it won't match an exit called get ball. So as you're watching me play around here, you can see that I'm basically either walking between rooms, which is basically a state machine, or I'm interacting with an set of exits which have different patterns attached to them. And that allows me to provide a much richer interface. So we can look at the window. So the window is an object, it's a thing in this database. But we can open it. And depending on how the database has been set up, either you have the same window object, but typically what you do is you have multiple window objects, and when you do some actions, it replaces one window object with another one, which has, say, a different description. I don't remember whether this is one of those. No, this is where they all have the same description. But this means now we can go west. So normally the window was closed, then we opened it, and now we went west. While I'm here, I better just do something else quickly. I can't see the chat, so let's go to the chat. Content live. No, that's not what I wanted. That's what I wanted, I think. Yesterday it was on the OBS. I don't want that. We'll get there in a moment. There we go. Yep, that works fine. Drag that over here. Okay, so I've got some chat. So in this room there are multiple things, and we're running, since we're a regular player, we can't see any of the hidden objects or hidden exits, so we're just limited by what the game will tell us. Now this is a real-time game, and there are multiple robots running around, or NPCs, in this database, and they're doing their thing in their real time. This is a multi-user database, I keep forgetting to say that, so you can connect in and play the game along with me while I'm on stream. So what we can do is, again, I said I set it up so that you could just click on these words and it'll do a get operation. There's a look in the room, so that the fireplace, windows open. Now in the too dark to see because we went up, so I can light the lamp. Oops, this database in Dungeons lamp on. No. Do I have the inventory? It is lamp on. Oh well, maybe this is the broken lamp. Haha. I forget about these things. There's another lamp. Let's get this one. Hey. So it's not the presence of an object called lamp, it's a presence of an object which has a command attached to it which says it has some light typically. We can do that, we can show that by switching to a different window. So tell me equals, that's teleport. It probably won't work because it didn't have the number. Oh, it is 377. Okay, yeah. Pound 3770. That's the database record object number. See, so here I am. So I just don't need that part of the command. So I can say as a wizard, which owns basically owns everything, I have commands which are not available to regular players. Let's see if that works. Nope. Okay. We can look at we can examine guest. We can examine 4013, the light. Now so one of the extensions of Tinymud was to add classes. Classes are rooms with a flag set, i.e. classroom, and so we can look at the lighted object class. And so the lighted object class provides a number of commands that lighted objects have, potentially. So we can light something with something. It has naked fire. The brass lamp probably doesn't. It has light. We can light it or turn it on. Obviously we can pick it up, and this is a large object. So for instance, we can use that property. So these are basically, yeah, we say these are basically properties, but they're actually they're messages. So we can send these messages to the lamp, and it will respond true or false, basically, depending on what we're looking at, what we're asking it to do. So if we douse the lamp, okay, we can just switch back to the other window. So we can say, and we switch back over here. We have a different, notice the lamp number changed. We switched lamps. So this brass lamp instance is should be of a different class. And so it's not a lighted object class. It is just a treasure class object. Now the treasure class objects in what I've implemented there is basically all the objects in the game that are not start off in a regular room, typically start off in some form of storeroom. And so the reset for that object or those classes will be to move the object to that storeroom when the game resets, putting them basically back in their original position. We can look at the regular treasure class. So it supports drop all, reset, which puts things back, home, which is probably the same as reset, hide, I'm not sure what that's used for, get, I don't remember what that's for, and then you can have an action associated with an object. So if you send an action message to an object, it will react. So we can look at, for instance, what the reset does. It doesn't do anything much. I need to improve put an editing pane in the web client. So the thing about exits and commands is an exit that doesn't go anywhere. It goes to it always goes to room 0, which basically is not ever taken. So you can't actually take an exit to room 0. But it does have a lock function, and then the lock function in this case is a move. It moves the receiver, which is self, to 3762, which is going to be the treasure room. And you can see there are lots of objects stored there. So we can light the lamp back over here. And obviously the thing is that the lamp is set up so that the commands attached to the lamp are world readable by other players in the same room, which is how the light. So that basically, as long as someone with a lamp in here has a lamp on, then the room will be illuminated. So this shows you the dynamic nature of this database engine. And everything is dictionary based. So basically all the exits and commands attached to objects can be thought of as a dictionary attached to that object. And then each dictionary entry may or may not have a lock function, and that lock function, if it exists, can return true or false. If a lock function doesn't exist, it's assumed to be true. the exits are only taken when the lock function is true. Now, when the message is sent to, say, a room or a player or a thing, there are two ways of sending a message. There's sending a direct message, and then there's sending a message to an environment. So, for instance, you can send, when I type something, it gets sent to the room, it gets sent to the player, it gets sent to things in the room, it gets sent to things the player's carrying, it gets sent to other players, and it gets sent to the things that other players are carrying that are in this room. I can send a message just to and that's done by sending a message to each of those objects sequentially. And all the objects that match are put into a list. Then the list is shuffled, and one of those, and then the list is the first one in the list is then the lock function is evaluated. If it returns true, then the destination is used. If it returns false, then the next exit in the list is tested, etc., until either all the exit lock functions have returned false, or one of them is returned true. So not only is there many dictionaries based on the objects and players within a room, if there's ambiguity, either there's multiple exits which match the same string, then the randomization and lock evaluation handles ambiguity. This is a very powerful technique and allows you to write some interesting programs. So, for instance, if in an environment all the lock functions return false ultimately, it does mean that they all got evaluated. So they can have side effects. So that allows you to basically do a for all type functionality. Or you can limit yourself to a specific object by just using a simple send to an object. So if you're don't understand or haven't experienced message passing thing, it's basically a function call. Nothing interesting about that. So amazing each object has a set of functions attached to it. The dictionary is used to select which of the functions is going to be evaluated. The function returns true or false, and it can have side effects on the database. So a side effect basically means it does something that it doesn't undo on failure. So let's get back to having a quick continuous play in the game. So we'll just do we'll get the knife. Oh, we don't need to be in this one. Wrong one. Knife's no longer there, of course. Yeah. This is a problem. I need to drop the knife. So I can do an inventory. I think I can just drop the knife. There we go. Yeah, I know. We try again. What? Didn't I do? Oh, well, I dropped it. Yeah, it's probably down in the room below, surprisingly. Nope, not down the room below. Okay, don't know where it went. If you play Dungeon, then you know that you can't take them, but you can move it. And so when we moved the rug, the function on that command moved a trapdoor object into the room from the treasure chest room. So the trapdoor itself now has commands attached to it which allow you to go to the room below when the trapdoor is open. So now we have what you don't see is that is a different trapdoor object, and it has an exit to it which is called down, which allows us to move to the room below. So here the exit was attached to an object, but it still worked as an exit because it had a destination which was not 0. It wasn't just a command. Whereas the get rug, open trapdoor commands basically were linked to the destination 0, so when the lock function was evaluated, you didn't move to another room. So the trapdoor being slammed shut basically is done through a robot who wanders around this area of the game. And if the trapdoor is open, it will shut the trapdoor. So read notice basically is a net command which basically says to the person who sent the command, sends a text back saying try, and then try look, and then the name of the object, which in this case was notice pinned to the wall. So when you take a single user game and make it multi-user, there are things you have to modify so that the game cannot be cheated on us too badly. There are reasons for that. Typically the trapdoor, when it's open, allows you to go back up, and you want to go back up because that's where you store all your treasures you've found in the game. Now there is other ways back which are just a little bit you have to discover in yourself, but going back up through the trapdoor was basically the original easy way of doing it. Now what we have here is we don't have a weapon, so if we go the wrong direction, we'll go into a room where there's a nasty robot. So we went south, we'll probably go south again. Okay, we can get the painting. And go south again. And there's a chimney. So we can, if we drop the painting, there. Okay, we can use the wildcard matching. When it's matching against the names of objects, allows partial matching, and as long as the partial matching is unique, then it knows it's identified the object that you want to send the message to. So you don't have to type in the full name of an object if a partial match will work. Okay, what else am I carrying? Okay. ambiguous. I think we go up now. So we were able to go back up the chimney. We really need that sword. So we should just click on it. Trap door is still here, but it got close, so we have to okay, we'll go down again. So we can go south again. South. South. So we can try get all. Nope, doesn't work on these. This part of the database. You could implement get all. I mean, it's no big deal. You just have to put a get all command into the default input somewhere in the thing object class. This is for this area, and make it just move the object to the player and then return false. And therefore, typing get all, every object that has that message attached to it will be moved to you as the player. We should have put lunch in the sack, never mind. Going around in circles again in this game. Non-Euclidean geometry, typically. Ah, we found the troll. Kill with sword. Yeah. Nasty little guy, isn't he? Attack, troll, sword. Hey. So in this database, it's attack, not kill. Oh, there you go. We should probably make those aliases. Hit, attack, kill. They should all be. You can make those aliases at some point. This database is 30 years old, so I don't always remember. I haven't played it for a while. Okay, so we can now go in any direction we like. Came back from there. Okay, Yeah. And we're going around in circles usually. Oops. Oh, yeah, down. Okay, we can go down now. Reservoir. Steep pathway. We go back down here. Go down. I can't go that. Go west. Okay. Let's see if we can pick that up. Oh, come on, game. $34 okay. Don't feel very well. That's a game engine thing. So basically, score. So the game engine implements for player objects health points, current health points, maximum health points, a level based on how many pennies you are, and your title is then based on your level. So we can show that, I think. There we go. So there is a female flag. So basically a player object can be male or female. Basically the way it works. The players can be given a class other than the default player class, and the first class that a player has is basically also called its title. So you can have titles which are not in this list. So this player is at 7. The dashed lines are boundaries where you have to perform a special action to get promoted across the boundary. So there is a promote capability in the game engine, and there's a promote lock function. As you die, if you get killed, then you lose pennies typically, but also you lose where you are in the level. Typically a third. If you lose a third of your health points, typically you lose about a 30 health points per death, roughly. Again, it's all implemented in the database as lock functions, but it basically is the lock function for health. For wounding, basically, is set so that you can typically die a few times. But here, as it says, that you'll be demoted if you die. So the engine provides that that level of messaging. Nothing on the chat yet. So where are we? South and east. This is where the glacier is, okay. You can't pick up a glacier, honestly. Yeah. So not all exits are obvious. Some exits are. Some exits are hinted in the description. Not always. So as we move around, health points go up and down. Now I believe that it doesn't matter which direction you point. So again, there the look W was an ambiguous reference. Therefore, it picked one of them, and it picked the one about the coil we were holding, rather than the wall. Now, it could have picked just looking at the look wall that does it easily. But it shows you how the game engine handles ambiguity. Now what we can do here, I forget, we can turn...
Hello. Welcome to Prism.
Yeah, that's right. We're using Chrome, so we can play with the...
Hello. Welcome to Prism.
Hello. You have entered a cave with passages leading north and southeast. Contents, wall with engravings. The engravings were incised in the living rock of the cave wall by an unknown hand. They depict, in symbolic form, the beliefs of the ancient peoples of Zork. Skillfully interwoven with the bas-reliefs are excerpts illustrating the major tenets expounded by the sacred texts of the religion of that time. Unfortunately, a later age seems to have considered them blasphemous and just as skillfully excised them.
Wow.
Pardon. Sorry, but I don't understand E. Sorry, but I don't understand S. Your compass needle spins wildly and you cannot get your bearings. You are in a round room with passages off in 8 directions. You don't feel very well. I am not sure what direction that is. You are in a narrow east-west passageway. There is a narrow staircase leading down at the north end of the room. You are in a deep ravine at a crossing with an east-west crawlway. Some stone steps are at the south of the ravine and a steep staircase descends. A chasm runs southwest to northeast. You are on the south edge. The path exits to the south and to the east. You cannot go that way.
Oh, chasm, okay.
You cannot go that way.
Chasm runs southwest to northeast. South edge. Okay, so we go east.
You are in a high north-south passage, which forks to the northeast.
Okay.
You are in a large room with a ceiling which cannot be detected from the ground. There is a narrow
Spelling
passage
mistake.
from the east to west and a stone stairway leading upward. The room is extremely noisy. In fact, it is difficult to hear yourself think. Contents, platinum bar. Platinum bar, platinum bar. The acoustics of the room change. You are in a large room with a ceiling which cannot be detected from the ground. There is a narrow passage from the east to west and a stone stairway leading upward. The room is extremely noisy. In fact, it is difficult to hear yourself think. Contents, platinum bar, you found a penny. Your hands are full. You are carrying, wire coil, brown sack, painting, glass bottle, leaflet, sword, brass lamp, providing light. You drop wire coil. Taken.
Yeah, I think basically the speech can be very annoying.
Welcome to Prism.
So here what it's done is that basically there are 2 rooms. The second room, the look command, moves you to the first room, so you get the same description exactly, and then silently moves you back. Likewise, but the difference is that in the first room there's a exit called asterisk, which matches everything you type, and so basically without apart from the word echo, it just echoes twice whatever you enter. Oops, H. So what that should have done is put us back in the first room. Oops, that's built-in command, that's not what I went. There you go. So get, basically, I think get foo just echoes what you type in after the word get. Which the whole point is that it stops you from picking up the platinum bar by default, but you can exit the room you're not limited to which way it is. There we go. North, south, southwest. Okay, we went east. Let's go east, south. Back in this room. Okay, doesn't matter which direction you go because it's spinning. Oh dear, we're in the maze. All alike. Yeah, go away, thief. He tends to steal anything of value. We got out. Okay. And we still have everything. Great. So how do we get to there? It's been a long time since I played Zork. At least 15 years. Let me go weird directions now. Yeah, this is a loop. Yeah, you can't go that way. Okay, the Banker's Zork. Okay, that's fine. Okay. What do we do here? Forget. Yeah, I know that. I remember it long enough. So I'm sure we had to do something with the cube. I thought we had to touch or rub it. What else did we have to do with it? Okay, what can I do? I just drop the sack here. Well, I should use... Okay, drop bottle. Get sack. Can I Put bar in sack. Okay, I can't, okay. Okay, get a bottle. I put the bottle in the sack. I think I only put the food in the sack. Yeah. And I don't have any food. They won't let me go north, I'm sure. Sure, rub cube. Okay, we can work it out. Okay, this is where we go start cheat. Oh, guess what? Isn't it? Equals pound 15090. Class default thing. Okay. That's weird. I thought there was something more to it. 4727. Yeah, I thought it would be too heavy to move. Maybe I haven't fixed this yet. Oh, we just have to walk through. Okay, that's what I think it is. 4741. Yeah, okay, so we just have to walk through the curtain. Nothing interesting. I assumed it was so. Okay, let's go south. Okay. Okay. Is that all I had to do again? Help me, Mr. Wizard. Three nine one six. 2361. I don't want next anyway. Destination is a command. So basically, the destination of this exit is this. A bank, walk, get. Okay. Walk through north wall, apparently. That's probably what we need to do. Ta-da! That was easy. Okay, so it's almost an hour is up, so some of the lock functions we just used are very useful. So for instance, we can, again, we look at this one here, which basically denies it. It's a simple one. So basically, the way messages are sent to the player is fail, and there's fail and success, suck. Fail and success, basically you give it a message, and that message is sent to the sender of the message, which in this case is the player. There's also what's called an other fail and an other success, and that message, if you have a message, is sent to all the other players in the same room. So when you say pick up an object, you'll probably say you picked up something, and the other players in the room, we sent your name picked up something. And that's how basically you can use that mechanism to talk to other players in the room. There's typically is a say command or a whisper command, etc. So these are some simple lock functions which are used a lot in this game. For some reason, I don't know, there is digs in this game, yeah, dig. So there is actually a table of built-in commands in the source, and the same table is used to match commands and describe and draw this table of comments, the comment. Typically the things are limited to 15 lines or so, and that's because dumb terminals in Telnet entered with a dumb terminal, you typically get 16 to 24 lines max visible. So we use 16, I think, as a default here. So we can look at page 2. On page 1. Zero index, obviously. So some of these commands can only be run by effective user ID of wizard, or the effective ID of owner of the command that the object is attached to, the lock is attached to. So these are commands. What's it called again? we have different messages in the command names, i.e. exit names, which are being used to match, or in bullx functions. You can have different things. You have a self as the receiver of the message, the sender, the location of the receiver, here, which is the room the receiver is in. Then we also have other ways of expressing the same information. So we have the $0 is the receiver, $1 is the first matched wildcard pattern, $2 is the second one. Because of the way commands work, there are also other variations which provide different prints formats for the same object. So for instance, you can do $0, but you can also $0. So it'll print out the object number of the rather than the name. And we also have some other letters like the class, the date, the time, and the name of the exit that we're matching. So there's a lot of, it's sort of some internal documentation in the game engine. So the Boolean expressions, which is a lock function, you have the simple and or operators that have a not operator. We have an at operator, which basically is it allows you to reference and lock in another object, another command. Then we have some age, basically is any time a lock expression is evaluated and returns true, then the age of the command is attached to is set to now. So that'll be basically 0. So what the age function does allows you to test if an exit or an object or a room is less than so many seconds old. And this is how timed events in the game are organized. As an example, the clock robot is in a room where one of the exits, basically when taken, sends a reset message to every object in the database, which puts the game back into its initial conditions for location of objects, etc. That start of that command has an age function which says basically age 3600. So unless the that's right. So the 8 is not age 3600. What that means basically is that until that exit's last taken an hour ago, it can't be taken again. So since the clock robot evaluates every 2 seconds all the exits in its environment, that exit lock function becomes true once an hour, after an hour's proceeded. So what it means is that no earlier than an hour, but after an hour, the clock robot may take that exit and then the game will reset. Okay, so it's been just over an hour, so we'll shut this stream down and think about doing another one tomorrow. Don't forget to subscribe and like, please, because YouTube likes when viewers do that.